Today we'll be looking into conversion of numbers. So as we all know, we don't just use one format of number, right? We just don't use decimal, but then we use hexadecimal, right? Hex numbers in short, and we also use binary, right? And if you can recall, right, in your electronics, digital electronics, or probably basic electronics, you would have seen conversions of different numbers from one format to another format, right? From conversion to say hexadecimal to decimal, from decimal to octa, right? So many things you have seen. So this is one such program, right, where we'll be looking into ASCII and hex conversion. So generally, this ASCII is used as a code in the keyboards, right? Whichever key is pressed on the keyboard, it's taken as ASCII, and the consequently, the conversion is done, right? So before we actually get into the program, let us let us look into how exactly this conversion works. Okay, just a moment. Right. So I think this is visible to all of you, right? The ASCII table. So we will be looking into the ASCII as well as the hex. Okay, so these two columns is what we are going to concentrate on, and yeah, so we will be looking into these as well here. Fine. So let us just take one example. Okay, and yeah. So let us see from here. Okay, if you just compare these, right? Is it visible, students? Let us just compare from 0 to 9. Okay, 0 to 9 in ASCII. So if you see that it is can someone tell me the difference between these two? We have 7 here, 37 here, 9 and 39. So can you come out with some pattern? Is there some pattern there? Is there some pattern between both of them? This is in ASCII and this is in hex. Okay, so 1 has 31, 5 has 35, 6 has 36. So is there some pattern here? Yes, no? Students, can you all respond? Okay, so you can see that here you have a difference of about 30, right? So this is applicable for numbers when we have 0 to 9. So let's say for example I have 9. Okay, then the equivalent is going to be 39. Okay, right. Now if we are going beyond this, okay, if we are going beyond this, then there's going to be some changes here. Okay, and now let's take A for example. A, if I add 30, I'm not going to get 41. Okay, and similarly F, okay, if I add 30, I'm not going to get 46. But instead there's a difference of about 37. Okay, there's a difference. Let us take this for example. Okay, yeah, F and 46. Okay, so F in ASCII should be 46 in hex. So there's a difference of about 37. So having understood this table, okay, we will try and get back to our code, and we will see how this code is implemented. So students, have you understood this table? Any doubts here? Can we proceed? Yes. Okay. So we are to write a code, okay, wherein we need to convert number from one form to another form. So we are concentrating here on Ascii and Hex. So, as usual, what we are going to do is we are going to give the initial declaration, right? And this is a small difference here, that we are going to use digit DCD and ampersand, okay, 0f. So this is the data that we are giving here, which means I want to convert f. Okay, I want to convert the alphabet f. So, and then we also use something called DCD. Okay, DCD is nothing but define constant double word. Okay, define constant double word, and it is getting stored. We are naming it as result, because in future we are going to use, or we are going to call result. So here, okay, we are going to load R0, okay, with a digit. So the digit here is F. So F is going to be loaded in register R0. So once this is loaded here, okay, then a result can be seen in R1. Okay. So how is this computed? How is this computed? We try to compare. Okay, we try to compare if the number is below 10. Now remember, I told you for 0 to 9 we need to add just 30. So which means we need to kind of have a comparison here. If the number that is given for conversion, is it below 10, or is it in the range of or is it greater than 9? So these are the two conditions that we need to check. So what we'll do here is we will just compare with 10, and if in case it is if in case it is within 10, okay, then what is going to happen, and if it's above 10, then what is going to happen. So these are the conditions. So actually your actual code is 1 2 3 4 5, only 5 lines of code here, okay, from here to here, and the rest is all just declarations, and where you're going to have your initial data, and where you're going to have your final data, right? So all those, right? So here what we're going to do is we're going to compare, and we're going to branch, okay, and we're going to branch to a label called add 0. So add 0 here, okay, it says if in case this condition is true, okay, if this condition is true, then it's going to jump to this branch which is labeled as add underscore 0. So why are we using this add underscore 0? Okay, so that we are actually trying to add data. Now here you see, okay, we are trying to add 30, right? So just just a moment. Yeah, add R0. This is going to be for yeah, 0. Fine. So this is going to be jumping to this branch here, add underscore 0. And what is it telling us? It is telling us add R0 with hash double inverted comma 0. Now here double inverted comma 0 is actually referring to 13 ASCII. So which means I'm going to add 30. So if it's going to be 7, then it's going to be 37. Okay. Then Now, where are we doing this? We are using register R0. Why is it that we are doing with R0? Because I'm taking the digit F. So F will be in R0. So to R0, we are adding 30. And okay, of course, we have taken a higher number here. So 30 is not going to be added. 30 plus 7 is going to be added. Okay, so just give me a moment. Okay, so here what we are seeing is, if we are using a higher number, as I told you, if it's going to be greater than 9, okay, then it's going to be added with 37. But if not, then it's going to be just added with 30. So here what is happening is, you should understand the comparison is happening with 10. So if it's true, okay, if it's true, then it's going to come here directly and just add 30. If it's not true, okay, if it's not true, for example, if we are taking F here, then what is going to happen? It is going to add actually 7 to R0, and then the next instruction is executed. So here 30 is going to be added, and once 30 and 7 is added, so it's 37, okay, then we have the conversion. So the main instruction here is going to be comparison of what data we have with A. Okay, so it comes down here, and then we are storing the data R0, okay, in R1. So because as we have seen here, R1 is given for result. So here, what is this operation doing? It is actually, sending the data, okay, to the pointer which is located, which is pointed by R1, okay, to that location. The data is actually changed. Okay, so the data of R1's address is updated with whatever is actually in R0. So R0 moves into R1. So here we can see that both R0 and R1 will have same data, right? So now let us look into the working out of this, so that we'll be able to understand. Okay, so are you all able to see this? Please give me a confirmation. Yes, no? Okay, thank you. Right, so we have taken a number F here. Okay, so as you know, F is all high. So this is how we are writing it in binary. So 0F, and so if 0 to 9, then we are going to add 30 to it. Okay, so here it's F, so which means it is greater than 9. So we are going to add 7 and 30. So we're going to take 7 here. Okay, so we are just going to do the normal addition. Okay, 1 1 0 and then carry 1. Okay, so we are going to do that, and we are finding out that we have the value about 16. Okay, 1 6 1 6, sorry, yeah, 1 6. And then next what we are doing is we are adding 3 0. Okay, so 3 is here. What we can do is we can have a logical bifurcation, so that you'll be able to understand. Yeah, so just treat this in this fashion. Yeah. So this is going to be 0, and this is going to be F. Okay, 0 7, okay, 1 6, and 3 0, right? So, and then once we have this, okay, 1 6 and 3 0, we're going to add them together, and this is going to give me the value, okay, which is in binary, okay, about 46. Okay, so here you have 8 4 2 1, so 4 and 4 plus 2, so 6. So 46 is going to be the final answer. So here, the main comparison that you're going to do is if it's below 9 or greater than 9. So accordingly, just add 30 or 30 and 37. So we will get into the execution, and we will see actually how it's done. Okay. Before I actually move on to this, let me also explain you another program, okay, where we are looking at the logical conversion from one form to another, right? Okay. Previously, we had used XOR operation. Can someone recall and tell me why was this XOR operation used in one of our programs? We had made use of XOR. So what is this XOR? Remember, we had used it for the swapping of contents from one register to another register location, right? So that is also a kind of logical operation. But then here, we are looking at or and yeah, XOR EOR is XOR, right? So the initial declaration is done. Okay, so here we are looking at the logical operations that will be performed. So initial declarations are done, and with R0 I'm giving some value. Of course, you can change the value and check for different logical operations. Okay, not limited to whatever is explained now. You can change the values of R0, R1, R2, and probably you can use other registers, and maybe you can increase the size of the data and take the help of another register to store the higher side, okay, the higher nibble and the lower nibble, okay, something like that you can probably try out, right? So here you have R0 has some data, then R1 has some data, and R2 we have given some data, right? So what we are doing here is we're using AND. The keyword is AND, okay, and R0 comma R1 comma R2. So what is this operation doing is, as we all know, R0 is going to be our destination, and there is going to be ANDing operation happening between R1 and R2. Okay, R1 and R2. So the result of this is going to be stored in R0. Similarly, the same thing happens with OR. Okay, R1, R2 is odd, and the result is stored in R3. Okay, and here R1, R2 is XORed, result is stored in R4. Okay, and here, okay, we have another instruction, okay, BIC R7 comma R2. So what is this doing is, okay, we are actually using AND inversion. So here, not of R2, okay, so whatever is the value of R2, so it is inverted, it is complemented, and to that value, okay, it is ANDed with R7. So ultimately you can see that the value in R7 is holding R7, whichever was there previously, okay, and R2 value, okay, the negated value of R2. Fine. And you have another instruction here, okay, which is BIC, okay, R5, okay, R2 comma R1. So here R2 comma R1. So here what is going to happen? It's going to take R1's negation, okay, and it's going to multiply with R2, and the final result is going to be saved in R5. So the reason why we have used these two instructions is to make sure for you to understand that if only two registers are there, how it actually works, BIC works, and if we are giving R2, R1, and R5, then how it works. Okay, so basically you should understand that R1's complement is ANDed with R2. If in case there are no other registers, okay, then we can only make use of R7 and R2. So here R2's negation, and we are ANDing with R7's value. Okay, so I will keep this as an exercise for you to work out manually. Okay, so take R0, take R1, and work out manually, and see to it that the values that you are getting in your software and your manual calculations are actually matching. Okay, so this is actually a pretty simple program where a normal ANDing is happening, ORing is happening, XOR, right? So the only new instruction that we'll be looking into here is BIC. Okay, now let us get into the execution, and we will see as to how these are performed. So I think by now all of you know how to write a code and how to actually check for errors and all those things, right? Okay, so as usual we have the startup file. Okay, so to that I'm adding number conversion, okay, that is which is nothing but your ASCII to hex. And one more thing that you can remember is that if you want to convert it back, okay, if you want a reverse conversion, that is from hex to ASCII, then we are going to make some minor changes. Okay, so just that instead of comparing with 10, okay, we are going to compare it with 3a. Okay, so this 0xa is going to be replaced with 3a, and instead of add, okay, we are going to change it to subtract, sub, and here also instead of add we are going to do a subtraction. So basically you should understand we are trying to compare with a different value, which is 3a, if in case the conversion is to be done from hex to ASCII. So this code written here is for ASCII to hex. So I'm going to leave that as a workout for you, where you're going to convert hex value to ASCII value. Okay, right. So we have the data here. Yeah, and one more thing that you should remember is we were adding 7 and then 30, right? So here we're doing the reverse. Okay, we'll be subtracting instead of adding 37. Right, so let me just translate. And we have 0 errors. Then we'll build it. You can actually make use of the ASCII table, and just check for any values, any random values, and you can see if those conversions are coming out proper. Okay, so the build is done. We'll get into debug. So I'm going to do a step execution, step-by-step execution. So you can see that R0 has got its value, which is F, and then R1, okay, the value of result, okay, the location pointed by result is actually given to R1, right? So next we're going to compare with 0xa, okay, that is with 10, and then the branching happens, right? We're going to add with 7. R0 is going to be added with 7, right? So we're going to get 16. Okay, we're going to get 16, and no, this is not going to happen. We're going to just someone try to add F with 30. You can go into the X mode, your calculators, and check. Okay. So finally, you can see that R naught is having a value of 46. So remember, the conversion was 46. The final value was 46. So this value now, okay, whatever is in R naught is being sent to R1. So this value should be updated here. So this 46 should come here, right? So the contents. So if we go to this location here, okay, 2000, right? Two and many zeros. Okay, I have actually pointed out here. So you can see that its location is updated to 46, the value. Okay. Similarly, you can even try, as I told you, conversion between, hex to ASCII. So you can probably change it to 3A here. And instead of add, you can use a subtract. Fine. So any doubts here, students, with this conversion? Okay. So similarly here, as I told you, we are going to have these values here are not R1, R2, and we are going to do an ANDing operation, okay, between R1 and R2. So, so you can just note down these values, okay, 5 and F. Now you know that how it is written, right? 0, 5 and 0, F, how it's written, and you can do a normal ANDing operation, and you can actually find out, how these are performed. So can someone just verify for me, okay, how this ANDing operation is done? So I want you to verify the result for me. So R naught will have ANDing result, R3 will have the OR result, and R4 will have XOR result, right? So you can see that here, we have used various registers for various operations, right? So R naught, R3 will be OR, and R4 will have XOR. Okay, similarly, we are using, one sort of instruction where it is multiplying with the negated value of R2, and here also we have the same thing, right? Same thing with a different set of registers, but then with R5, right? So quickly what we will do is, we will just verify and see if, the value with R0 is fine or not. So can someone help me out with that? Chandramohan, can you do that? Tell me what value should be in R0. So by then I'll just add this. And just build. Yeah, we have 0 errors. Linking is fine. Translate and build is fine. Okay, so you are able to see here that this value is loaded to R0. Okay, similarly R1 is updated, R2 is updated. So we have these data here, and now we are going to manipulate, or we are going to change R1 and R2. So can someone help me with R1, R2? Just check if these values are delivering. Okay, so you should be able to see 5 in R0. Okay, so if you can take 0 0 0 0 and then 0 1 0 1. Okay, so that gives you 5, and then 4 zeros, then 4 ones. So it's going to give you a high value when you add, only when there is 1 1, right? So 1 1 is going to be corresponding to only 5, so which means the value is going to be 0 5 at the end, right? So that is going to be stored here in register R0. Okay, so similarly you can try and compare the values, okay, as to how we are getting this XOR. Okay, are these values correct? And you can even check for this BIC, okay, and uh, put that in your observation notebooks, right? So that you can actually verify those values which you have got through, this simulation, as well as those values which you have manually calculated. So any doubts here, students? Okay.